Hello, and welcome back to our Introduction to the C Programming Language. This is session number 10, our last session. Quick recap from last time. We went into the details for operators, expressions, Boolean logic in C, the casting, and the conditional operator. This time we'll be going into flow control in your program and have a brief bit about programming style. So, flow control. In C, flow control is how you change what parts of your code run under certain circumstances. If you just had to write one set of instructions that always ran every single time, you wouldn't be able to accomplish very much. A lot of things are very situational and conditional. And so, to start out with, we have the if statement. If what is a keyword in C, and so the syntax you can see right down here. So you have if, open parens, some Boolean expression, close parens, and a set of braces. If the Boolean expression evaluates to true, which means if the expression evaluates to anything that isn't a zero, everything in this set of curly braces will fire. If the Boolean expression does not evaluate to true, then everything between these sets of curly braces will fire. This else is optional, so if you don't want to do anything if the Boolean expression is false, then you just don't include the else or these braces. Important to note, you don't have to have these braces if you're just going to fire one line if the condition is true. So for example, if you're just looking for if something is true, fire one printf line, you don't need these braces. And many programming styles will not appreciate having those braces because it makes someone assume that something more is happening there, and it kind of just takes up space on the screen. So the else is optional, always. The braces are optional sometimes, but the if bit here, you always need that. Motorcycle. So, the if statement is pretty simple and you'll be using it a lot. So, switch statements. Switch statements are probably the most powerful construct in C. And what they do is, an easy way to think about them is they're like a whole bunch of if-else statements chained together. Except that's not quite true. The main difference between them is, whereas a chain of if, else if, etc. statements, the conditions all have to be evaluated one at a time. With a switch, the expression is only evaluated once, and you can see the syntax here. The expression is only evaluated once, and then it just immediately jumps to where it needs to go. I have an example in my text editor that's a little bit more detailed than this, so let's go over there now and go over this. As always, this code will be available on the site. So, here's what we got here. We include standard IO and standard lib.h. In our main, first thing we do is we ask for input. What I have here is just a character array to hold our input in. fgetS, I mentioned when we went over file IO. This is a safe way to get a string from a file while knowing that you're not going to overflow the amount of space you provided for it. And then what we do is we call a function called a to I. This is ASCII to integer. We pass it a string, so we pass it our buffer, and we get an integer back out. Then we switch over I. A few things to notice here. I skipped the number 2 in my cases, so we have a set of cases here. And these are all of the different possible values of I that we will deal with. So I have 0, I have 1, I have 3, I skipped 2. You don't need every possible case. The numbers 6 and 5 are out of order, so they don't have to be in any particular order. And you'll notice that case number 3 has no break. After most of the other cases, I have a line that says break, and you can see by the highlighting that break is a keyword in C. What this break does in these circumstances is it exits the entire flow control construct. So when we get to this break here, we just exit out of the switch and continue to the next line, which in this case is this printf. If you don't have a break here, the slides say the break is optional, but that's not quite true. If you don't have a break here, what happens is something called fall through. Instead of stopping here after the printf, what happens is we just go to the next line here. So we ignore the case because that's part of the definition of the construct. This is the next executable line of code we find, and so we execute this line and then hit a break. So what happens here? Let's run through all of our cases real quick before I test this out for y'all. So if I equals 0, so if we type 0 into our program, we set I to 1 and break out. If it's 1, we set it to 2 and then break out. If it's 3, we set I to 12, then we printf falling through, and then we set I to 13, break out. If it is 6, we do nothing and fall through, because again, we don't have a break here. This is one of the examples where fall through is actually something you want. If you want to do the same thing for multiple cases, you can just type it like this, and you won't have a break, so you'll just fall through to the next one, so they'll all do the same thing. If it is 6 or 5, we add 2 to I. This is a special kind of operator called the addition and assignment operator, or plus equals, and this is equivalent to I equals I plus 2. Very, very useful, and something I kind of glossed over when we went operators because they're kind of special. And then, anyway, after we I plus equals 2, we have a break here. And then there's the default keyword here. Default is what fires if none of these cases are applicable. So if I is not 0, 1, 3, 4, 6, or 5, then the default case fires, in which case we set I to 322 and we break out. And then at the end, after we've done all of this, we just printf the value of I. If you remember, the %d means we're going to send printf an integer. Then the /n means there's a line break afterward, and I is the integer we're passing. So let me pull up my terminal here. Let's see, can I zoom in a little bit? So let's GCC it. Almost forgot. Cool. And now we will input a number for I. Let's start by just doing 1. And we get a 2 back. That's what we expected. Do it again. This time we're going to try 4. We get 13. Let's try 3. We get the falling through message, and we get 13 at the end, demonstrating the fall through I mentioned earlier. Switch over. Let's try 6 this time. We get our 8 back. 6 plus 2. 5, we'll get 7. And that is our 5 plus 2. And for our last one, I'm going to put something weird in. Let's say just that random number. Oh, I tried to pass that as an argument to the program. That was my bad. We'll try that again. And we get our 322 back. So that is a pretty neat little sandbox for you to play around with the switch statement in. I'll add some comments here explaining what these 3 lines do in more detail before I upload it, but that should be a pretty useful place to play around with it more or less consequence-free. Back to the slide deck. What do we got here? Next up is looping constructs. There are 3 main types of loops in C: the while loop, the do loop, and the for loop. What all of them do is they are designed to repeat a chunk of code over and over and over again until some condition is met, or rather not met. And basically what these all boil down to is the while loop, give or take some conditions. So the first one is the while loop. The while keyword is what's used for this. Then you open parens, you have some Boolean expression, so something that evaluates to, well, any number really, but it'll be considered false if it's 0 and true if it's not 0. Then you have a set of curly braces and some chunk of code in here, so you can have a statement, multiple statements, many lines of code. And so what happens here is, first, we get to the line of code that the while is on. We check the condition. If the condition is true, we execute everything between the curly braces. Then we jump back up here. We check the condition again. If it's still true, we execute that, and we continue that pattern until we check the condition and we find that it is not true. When we find that the condition is not true, we skip everything in the curly braces and just go to the next line. It's pretty simple, and you can actually create infinite loops doing this by just saying while 1, or while anything that isn't 0. Usually you're not going to want to do that, but it is possible to do. So, moving on here. Do loops. Do is very similar to the while loop, with one caveat. In a while loop, you'll notice that the condition is evaluated first. In a do loop, it's evaluated last. So what this effectively means is everything in the curly braces is guaranteed to fire at least once. So the syntax here is we have do, we have our opening curly braces, everything we want to do in the loop, and then the while condition bit here. Another thing to note is that while loops don't need the semicolon at the end, the do while loop does. And again, this is relatively intuitive. So we get to the do line, we go into the curly braces, we run everything that's in the curly braces, get to the end, we check the condition. If it's true, we jump all the way back here, run it all again. To the condition, and if we find it's false, then we just don't jump back. What we do instead is we just pass this and go on to the next executable line. Last one is the most complicated one, and ironically the one you're likely to be using the most. This is the for loop. The for loop is best explained as a kind of syntactic sugar around a while loop. Usually for a while loop, you're going to want to run things just a set number of times. So the for loop is here to kind of get all of the information necessary for that in one place. In the parens of a for loop, 3 different statements are expected. These are generally called the init, the condition, and the increment. They are separated by semicolons, so you don't put a semicolon after the last one here. And what this does is, first, when we get to the for loop, the init statement is run exactly once. Then the condition is checked at the top of the loop. If the condition is true, we run everything in the curly braces, and when we get to the very end here, before we check the condition again, we run whatever the increment is. So I have another page here that shows that these two are basically the same. So what we get here is we have the regular for loop syntax here. So for init condition increment. And And what happens here is we hit the init, then we go to the while condition, we do all our loop stuff, and at the very end we increment. Usually what's going to happen in the increment step is that you will run one of the plus plus operators. Like, for example, I can type that up here. So let's say int I for int I equals 0, I less than 10, plus plus I. Do something 10 times. This is the most common kind of for loop that you'll be using. You'll just set something to 0, say as long as that something is less than some number, plus plus I, and then you'll just do something however many times. You'll find yourself tweaking this a lot, so you'll find that this can actually be more or less anything. So say I plus equals 2. You could equals some other value, so let's just say j plus 5. You can do more or less anything in here. Similarly, the init can be multiple assignments, so you can say j equals I equals 0, j equals 4, I equals 0, something like that. And this condition can be any Boolean condition, so I not equal to 100. Do the same thing 100 times. The way you style all of these is largely a matter of preference and how effectively you can communicate the ideas that you're trying to program to yourself and other programmers. This is something I highly encourage you to play with on your own, and I believe some of the mini projects will be dealing with this directly. So, here. I mentioned programming style a few times over the course of this, and now we're going to get into the detail about it. Programming style is something that's personal to every programmer, and it is rule of law in among certain groups and like programming teams, companies, any other kind of organization that needs to be able to share code. Generally, the programming style is a set of standards put in place for how you type your code up such that people can easily read it if they know the style. This doesn't necessarily mean that they know what it's doing, but it does mean that they can generally look at it and get an idea of what's going on. There exist tools within text editors and IDEs to style code automatically for you according to whatever rules you put into place inside the program. My personal advice, and this is what I did when I was first learning to program, find a commonly used style that you like, something that looks nice to you, something that makes sense to you, stick with it, and if necessary, use these tools to change to the preferred style of your organization. There are a handful of things that go into style, such as the curly brace style. You'll notice that in all of the examples here, they put the opening curly brace on the same line as whatever causes that curly brace to be necessary. But the style I use, you'll notice I put them on their own line. This makes it easier for me to read, and some people find this very difficult to read. Matter of personal preference. Other things, naming conventions. Different people will name their variables in different ways and make them readable in different ways. The fact that we can't use spaces makes it so that we kind of have to come up with a convention for this. So sometimes people use what's called camel case, where they'll capitalize the first letter of every word in a variable's name if it has multiple words. Kind of looks like the humps on a camel's back when it's capitalized. Snake case is what it's called when you have everything lowercase, but you separate the words by underscores. Hungarian notation is a kind of weird name for a kind of way to hint to yourself what data type any particular variable is. So, for example, a string will have a lowercase s in front of it. An integer will have a lowercase I in front of it. A float might have an f. Naming conventions are something that programmers squabble over constantly. So, again, find something you like. Line length. In the old days, terminals only were able to support 80-character long lines, and after that they would have to break and wrap it around. So some places and some people like to limit themselves to 80-character long lines before they put a break in themselves. Some people do 100 characters, some people just don't care, because, well, modern text editors will let you scroll as long as you need to. It's just find something that looks nice to you. Indentation. There are two main schools of indentation. There's using spaces, and then there's using the tab key. I generally recommend using spaces because it gives you more granular control. But basically, when you indent something in your code, you're using it to signal that this is part of a different chunk of code, part of a different scope usually. And so what people will do is, instead of writing everything on the innermost line, they will indent it by hitting space a couple times. I use 2 spaces, some people use 4 spaces, and some people use tabs, which are all 1 character. Usually a tab is about 4 spaces in width. I have my editor set up so that whenever I hit tab, it actually just inserts spaces instead. Ultimately, it comes down to whatever helps you work, whatever helps you be able to read your code, and whatever helps you be able to read the code of others. Programmers get into arguments all the time about which style is best and which one is readable. The style I use tends to be pretty close to how the original writers of C wrote their code. At least in one of the books I've read, I think. But all styles of C are valid, all styles of C are beautiful. Some of them are just more beautiful than others to me. Let's see. I think that's it. Flow control is a very fun thing to play with, and it's very important to learn how to use effectively in writing your code, because as things get more complicated, you're going to need those flow control constructs more and more. Code style is very personal, and programmers get into holy wars over them all the time. As always, there are live coaching sessions for C. And software design and engineering in general. Because this is our last one, I'll go over some other classes that are available on the codingbootcamps.org site. .org, actually? Let me double check. .com, my bad. Codingbootcamps.com. So you'll have an introduction to Python, introduction to Java, introduction to Golang, introduction to Kotlin, with a more hands-on examples. Follow-up classes to this include intermediate level C with hands-on examples and C++ programming by examples. Hope you'll join me for those. Thank you for joining us.